Hi everybody, in this video we are looking at example 2 of section 1. Section 1 is exponential functions in the unit on exponential and logarithmic functions. And in example 2 we are just going to graph a very basic exponential function. So this exponential function is in the form of y equals a b, which I prefer capital B, but I guess we could use lowercase if you'd like, a times b to the x, although I'll use capital. Now the y is, of course, in this case, f of x. And then we have our ab to the x, which is the 2 to the x. When graphing, a is what we like to call our initial value. That is where you are starting your exponential journey, whether it be growth or decay, in regards to the location of the HK, the crosshair of the shift of the graph. In this case, it's at 0, 0. We have nothing shifted around. I'll show you that in a moment. B is either your growth or decay factor. In this case, it's going to be, which one? Hopefully you know. So as we saw in the last example, when it is greater than 1, we call it growth, and when it's less than 1, it is decay. So what's our initial value? It's not 2, right? Oh, this is a little squashed. I don't really like how that looks, sorry. So the initial value is not 2, right? Because 2 is your actually decay growth factor, sorry. And our initial value is a 1, because really we have y equals 1 times 2 to the x, okay? So our initial value is 1, and our growth factor is 2. That means it's really a 1 plus 1. That means you start with 100% of something, and you're increasing by 100%, which means you are doubling, right? So an increase of 100%, so increase of 100% is equal to doubling of your value, okay? What else can we say? We could also, before I just continue, this is x minus 0, and then on the side is plus 0, meaning it moved left, right 0, and it moved up, down 0. So those are your HK, so we can sort of just disregard that right now. That 0, 0 is your crosshair right there. Now, if I go ahead and start plotting these points, my initial value is 1. That means 1 unit up from that spot right there. And then that distance, you kind of think of it as a bar graph for a moment, like up 1 unit. My next spot will be up 2 units. The next spot after that will be double that. It's up 4. Then we're going to double that. That next one's up 8, and so on. But you're not drawing a bar graph. We're just drawing a graph. So up 1, up 2. The next one's 4. That's doubles. Then we have 8. After that would be 16, 32, and so on. But as we go left, we take half. So that's 1/2. There's 1/4, 1/8, 1 over 16, 1 over 32, 1 over 64, 1 over 128. And what's going to happen? It's going to get closer and closer and closer to 0. It will never reach 0. So we describe our end behavior on the left as approaching 0. We could describe that end behavior using terminology, language like a limit. So we would say the limit as x approaches negative infinity. That means as our graph goes to the left, the limit of f of x, that means your output value, your y value, is doing what? Well, in this case, it's getting closer and closer and closer to 0. And many of us consider that our horizontal asymptote, but I would rather call it end behavior, because if you think about it, this dotted line that we draw here at the location of y equals 0 is sort of silly, because on the right, we're not going to 0, right? As we go to the right, if I look at that limit, the limit as x approaches positive infinity of our function f of x, well, now where are we going? Well, where is it going? Up, 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 and away. So you're going up to positive infinity, right? So a lot of things that we could talk about. End behavior is a better way to describe what I like to think, at least it's a better way to describe our, in this case, horizontal asymptote. We have an exponential growth, very basic, and that is all that it looks like. So hopefully you understand the very basic logistics, no pun intended, of graphing an exponential function. And go ahead, check the playlist, the entire unit, and check the next click through. If you love it and you love it and you want to show it, thumbs it up. If you hate it and you would love to let me know, give me a thumbs down. Questions, comments, concerns, feedback, requests, put it in the comment section. And bye for now. Adios.